the railgun.
That's a fun
There's a
problem.
trick to that.
Yeah?
I've forgotten what it is.
Something to do with
It's
some
elegant.
It's equations in the book somewhere.
No.
I don't know how to do part A without Jen kind of just claiming that it's true.
Let me look
I-
at that. There's a bit of circular reasoning in this.
Yeah.
Are you recording me?
Yeah.
Yes.
There's a bit of circular.
If I remember correctly. There's a chance that I'm going to have to go downstairs and look at my solution.
Okay.
I don't.
Because I can't. I
Start
just
from the page for this.
find
You
a
got
way
it?
To
So,
answer the
yeah,
problem
it's-
without just claiming that it's
So
true.
the two things is the energy of the
That's how
the
we
energy
really
of
want
the
this too.
passive, or the energy to keep the current constant.
Getting chapter 8.
You've got
Ah, yeah.
you've got you have V equals
Which I
and
suppose
then
for you
so
people
dV
would have
equals
been
I.
Is V
IDL.
equal to IL?
No, it
So
would
I
be one.
IVV.
Q
would be
is
the,
one
um,
as well.
IV
No, you went over
would be
chapter
what
8
would
and
be
the Tom said.
work because it's I times the voltage
In modern physics.
Yeah.
equals I squared DL.
Townsend book
And
was
that's how
that.
you get that.
So if you went through
And then the
all
other one
of
is just
all
U.
of that,
So
all
you
of
then you
that,
have this,
yes.
which really you
All
could have
what?
just started
All of
with
that
because I could have
yes.
told you
Yes.
Okay.
And
so
then-
quantum physics
and
one,
then you have
textbooks,
L,
chapters 1 through
that,
6.
and then you take the
Quantum
then you
physics 2 is
DL
in
that,
textbooks, chapters
and then you
7
have
through
to
10.
get that D. Then you have to do something in terms
quantum
of.
physics freshman back
And you
and
have
said, you
this.
know what, this
So you have,
this quantum
you have
physics book
DL
actually
equals
isn't that
this
good, so
dx,
we're going to go back
but
and
this
use
is
Townsend.
also
Yeah,
to be
that's
written as
right.
L over X. This term can be written as L over X over C, L over CX.
Yeah, that just needs to be honed a little bit. You've got everything that you need. By honed, I mean, you were pointing all over the page.
Oh yeah, because my work is all over the page because I did this in like an
Yeah.
hour and a half an hour to an hour.
Okay, so I might have, so you're going to talk to everyone else while I run down and take a quick look at my solution, which is like 3 lines, if I remember correctly.
Why is it always 3 lines with you?
Because
It's
if it's
not.
doable,
Well,
well,
sometimes
okay.
it's 4.
Sometimes, yeah.
Because if it's doable, then he already knows what
So
to do.
at some level, I confess that I'm cheating with the 3-line solution.
Okay.
In the sense that all I'm doing is laying out the logic for how you would solve this problem. And then, and as far as I'm concerned, when I do that, the problem is solved because the rest is just arithmetic.
That's why Ohanian thought 5.05 was like, just do the integral, that'll be easy.
Yeah. And then I have to be careful about sometimes the arithmetic is hard.
Yeah, that doesn't help me.
But most of the time, I'm just saying, oh, it's that idea, that idea, that idea. And that's what I'd like to boil this down to. And probably better if I run down and check my solution before I. No, you can go ahead and talk. He'll keep you busy while I look at my solution.
So first you need
Is this,
the
wait,
TA
is this
Riot?
Is this 10.20?
Yeah, this is 5.20.
So that's just U of any. That's a U of any field of like any
Yeah.
circuit. So
Any, yeah.
so
Any
du dx or the u dx equals 1/2 I squared because I is constant dl dx or du equals 1/2 or I squared dl over 2
Is
dl.
that little u or big U? That's big U.
So that's big U. So then you've got what the other thing you've got is you know that work equals U2 minus U1. In other words, it's the delta of potential energy. So dW equals du2 minus du1. The negative du1, negative du1 is just let's see, where is it? Negative du1 is just negative, or is just 1/2, or is this I squared over 2, or actually, no, it's negative I squared over 2.
I squared over 2. You destroyed the 2.
So it's I squared, or not okay, 2 du. DL. Yeah, DL. Because you've got because that depends on who you declared the work being on. And my declaration of work direction was wrong there. So then you plug that, you got work equals U2 plus I squared over 2 DL. So the thing, oh wait, no, wait, I had it right the first time.
Yeah.
So the thing that's missing is you want U2.
Yeah.
So U2 in this case, you're asking the work to keep the battery voltage
Oh,
constant.
you just moved the term. Okay.
So
That's
you-
pretty cool.
Yes, U2.
Isn't that an integral?
So you got the voltage is negative I dl, or the voltage is dx I l, which is an equation I knew from doing physics 2. Usually they move the I to the dx to the dx to the I, but so that means the voltage is equal to negative I dl dx, or dv equals I dl. And you know that IdV is in fact, like, so it's, you know, you have Q, QV is U, so IdV is du, IdV is d, IdV is du, so then when you sub that in, you get du, which would I name this one, 2 equals IdV equals I squared dl. And then you saw, I mean, that's completely pointless that we had to do this, but that I had to do this because I could have declared it from the beginning. But it's dw equals 1/2 I squared dl. And then you know what L is. So if I might have made a few mistakes here and there, but I see B over I by the definition of phi, which is just phi B over Ci from the definition, which means DL is RB Ci dx. And this term is also just dl equals L over Cx dx from the fact that from up here. And then you plug that back in and you've got where this is just the inductance per length, and they've got the right units and everything. Pretty sure, but not positive. We can find out when Cassandra comes back.
What's the say right there? It says du2 is equal to I, looks like an alpha, that should be equal to d.
Because that's what a that would be
Yeah.
might be W there. Whatever. And you plug them back in. That's what I got. Me? I'm assuming he knew I was going to do the whole problem, or what I thought the whole problem was moving forward, but
And that expression is down there. That's just.
I never finished plugging in. You have this, and you plug it into here, and then you move the x to the other. You divide by x because that's just what.
Yeah.
That's just the 4.
Well, don't you need the x in there for the second part of the problem, or?
Well, no. We'll finish that one. dw equals 1/2 I squared. Plugging this in, L or I squared L over Cx. And then move the dx to the other side, and that's just f is equal to that. Oh, glad I did. I think it's right. No, I did it wrong. Well, some of those signs were kind of questionable because it's work. You have to declare which
Yeah.
one's doing the work correctly. I just assumed on the signs.
Oh, does that work with the negative, with the central energy? The negative.
Depends on which one who
Yeah.
you're talking is doing the work.
Yeah.
What does that L equal? Equals Rx over C times B over I equals.
That's phi b, that's the magnetic flux over Ci, which is the definition of L.
Got it, thanks.
I mean,
Threw me for a loop because there's no loop through that I.
Just,
oh yeah, I'm assuming the phi.
Also,
Pretty sure that might be right. So, in effort to make so you guys aren't just copying my work,
I just needed that one, please.
Oh, that was a, okay.
Except the fact that this will be online tonight.
it will. That's fine.
Tar.
Except for nobody actually
Oh,
watched.
you should have given us the equations that we needed to combine, and then.
Keep
I didn't find my solution.
It's probably on Long Island somewhere,
Probably, yeah. Done?
essentially.
All
I think
discussion
mine was
over?
right. I think mine was right. Signs are iffy just because I hate work, but
You're right.
He
Good.
hates
You're
the
such a good
definition of work,
physicist.
not
You're-
actually doing work.
no, I hate the signs on how you do work. Like,
How you define work
how you define
conventionally,
work.
like
Oh,
up
yeah.
to negative.
That just is like-
like.
magic sign, this problem works. I mean, I don't know if my answer was technically right,
I'm
but
gonna solve the problem.
Oh, then,
yeah.
the units were correct.
And then figure out which ones have to be correct.
Oh, then.
And then-
Yeah, I say don't worry about the sign,
energy,
it'll all
right?
work out in the
We
end.
let work equals
Yes,
change
yes,
to
we will
energy,
make it right out.
and then it's going from rest to this new speed.
Was X the
Right.
distance?
Yeah. Yeah, so.
Was X the distance along the length of the gun?
Yeah, that was what we were given as the distance. R, the line named R was just the width of the rails. But you didn't need, that wasn't in the final answer. It worked, since you had L.
Okay, that's good, this is right.
So could you convert, I mean, I don't know if my
They
answer,
didn't give us R at all.
well, the rails have a width. So it doesn't end up in the final answer.
Doesn't.
Yeah.
You mean the
Well, first